This is problem 6.1, and we're going to learn a little bit about second order circuits. And here we have an RLC circuit with a resistor, an inductor, and a capacitor. And we need to figure out various different quantities, VC at 0, IL at 0, and so forth. So we have that the SPST switch closes at t equals 0 after it had been opened for a long time. Draw the configurations that appropriately represent the state of the circuit at t equals 0 minus, t equals 0, and t equals infinity, and use them to determine all of these things. So let's look at t equals 0 minus. So the switch had been open for a long time. So that means the inductor acts as a short circuit and the capacitor acts as an open circuit. So we would still have we have our voltage source, and we have the 3 ohm resistor. Our inductor acts as a short circuit. That wire down the middle doesn't do anything. We have a 4 ohm resistor right here. Our capacitor acts as an open circuit. Okay, so at t equals 0 minus, there is no current anywhere. So we have that IL of 0 minus equals 0 amps. And we know that current can't change instantaneously through an inductor, so IL of 0 must also be 0 amps. The voltage across the capacitor, well, this side, if we make this ground, this side is at 0 and this side is at 12, and so our capacitor, our voltage at time t equals 0 is 12 volts. And since voltage can't change instantaneously, the voltage across a capacitor, the voltage across the capacitor at time t equals 0 is also 12 volts. So now let's look at what it looks like when time t equals 0. Well, right when the switch is thrown and current starts to flow, an inductor is going to act like an open circuit, and a capacitor, if it's charged, will act like a battery. If it's not charged, it'll act like a short circuit. So that's right when you throw the switch. So let's see what it looks like. So this is 12 volts, 3 ohm resistor, and we have our inductor, and we now have a short circuit down the middle. We have a 4 ohm resistor, and we have our capacitor, which was charged, and it was charged to 12 volts, so it's going to act like a battery that's 12 volts. Right at the very beginning. So we have this 4 ohm resistor here. And now we want to find out what is the voltage across the inductor and the current through the capacitor. So we have IC labeled here, and we have VL labeled here. Okay, so thinking that this acts as a battery and making this ground, then the voltage right here at the beginning is going to be 0, and the voltage right here is going to be 12. So if we think about the current across this resistor, so that's going to be I, that's going to be the same as the current through the capacitor. So IC of 0 is going to be the change in voltage, 0 minus 12, over the resistance, which is 4, or negative 3 amps. So that equals IC of 0. Now let's take a look at our inductor and find out what its voltage is. So we have this side is 0 and this side is 12 from the power supply, from our voltage source, sorry. So this is 0, this is 12. So the voltage on our inductor at time t equals 0 is 12 volts. Alright, now we need VC at infinity and IL at infinity, so let's draw the circuit as it looks at infinity. So now, at infinity, the inductor is a short circuit. And our capacitor is an open circuit. And we wanted VC at infinity and IL at infinity. Let's see, IL at infinity. Okay, so again, if we look at what's going on here, we can say if we call this ground, then voltage here is 0, voltage here, well, voltage here is 0, voltage here is also 0, connected to ground. Voltage here is 12. So if I want to find the current here, which is the same as the current through the inductor, then the current through this 3 ohm resistor is 12 minus 0 over 3. So this is IL at infinity, which is 4 amps. Now let's look at our capacitor. The voltage everywhere here is going to be 0, same as ground. Voltage everywhere here is going to be 0, same as ground. So the voltage across the capacitor at infinity will be 0.